Alright all, Scott here again, and we are running a defective TXV right now. A blocked TXV valve. And a TXV is a thermal expansion valve. There's some great little videos and pictures, I'm sure, on Google if you want to look at the X-ray version of what it looks like on the inside. It's basically springs and a sensing tube and a bulb. Pushes on it and expands it and contracts it as needed to hold the ideal superheat. In this case, the TXV is not working correctly. I guess I'm going to need to, well, I'll show that in this one what it looks like when it's running properly. Our superheat, let's see, our evaporator is 53 degrees. That's kind of high for the suction line. And we are 53 degrees at the evaporator, which is zero superheat, no superheat whatsoever. We have 115 degrees on the high side, condensing side, which is a little low, and we have a 10-degree subcooling. The supply temperature is, supply air is blowing at 78 degrees, and we just can't bring this indoor temperature down anymore. Our differential, no, it's not going to give me that check. Essentially, it's just checking right there at the bulb. Curious what our outdoor condensing outdoor air is. 115, no, 110. It's always 5 degrees less than what it's changing state at. I haven't run the discharge line much. Let's see what we're discharging at. Discharge is 157 degrees. Look at our repair. Inadequate cooling. This could be TXV improperly set. Let's see. It's odd, it won't let me choose that. Do have pretty high suction. TXV is stuck open. So in that one I selected high suction pressure, and possible scenarios were TXV is stuck open, could be improperly set. I'm just curious what it would save. But if I hit that one, it allows me to test it. So you know when you've got the right one because it'll give you the option to test. Let's try a different one, see what it does. Oh, this one allows you to test it though. Well, I know that it's stuck open. Measure the suction pressure and the superheat. This problem causes high suction pressure and low superheat, which is what we have. Going to do the repair. And let's see what happens. The system's going to run at a 60-to-1 ratio. It's going to run fast. Let's take a look at our liquid line there. Let's take a look at our suction line. And let it run for just a minute. Let it balance out. The temperature inside is dropping nicely. Bump that temperature up. the system run. Lock it in temperature. We're going to lock that indoor temperature so it keeps running. And now we can see the evaporator is changing state at 40 degrees, which is 69 psig with R22. And we have a 10-degree superheat. So this TXV is holding this open just enough to have a 10-degree superheat. The condenser is changing state at 120. So that's normal on your high side. And on the suction line, actually, let's move this to supply air. We have supply at 56 degrees. That's a 20-degree delta T from your indoor temperature. And this curious air compressor discharge is discharging at 171. And I imagine this temperature blowing out of the condenser is going to be 115 degrees because it's always 5 degrees less than whatever the change of state is. So that's what our normal running system is with the TXV. Runs a little more efficiently than a fixed orifice or a cap tube, typically. My tip for today is if you have a TXV that is not adjusted correctly, just get a new one and put it on there. It'll take you forever to adjust that thing just right. Alright, that's it for this sim.